So this is a demo of the Adafruit 16-channel PWM Servo HAT for the Raspberry Pi. This card has been around for a long time. I'm not even sure if you can order it anymore. I had worked on this quite a while ago, and I've pulled it out and blown the dust off of it. What I was trying to do with this, which is a little different, is I wanted to get this guy working with C++. And I also wanted to be able to control it from another PC. So over here on my camera you can see the hardware setup. So I have two servos. I have a rotational one and I have a positional servo. Here you can see the Servo HAT, which is attached to the Raspberry Pi, which is under it. I don't know if you can see it like this. There's the Raspberry Pi. And then I have, this is a Raspberry Pi 2, and so it doesn't have onboard wireless, so I have this little guy here for the Wi-Fi. And we have a 5-volt supply coming here for the Adafruit board. The board has 16 channels. I've plugged the rotational servo into the first channel, which I'm calling channel 0. And I've plugged the positional servo into the 4th channel. So when I talked about C++, what I meant was the library, which Adafruit is trying to sell us this one, which is fine. It's a Python library. At the time, I took the Python code and I basically implemented the same thing but in C++. The basic the main class here, the PWM class, is going to be almost exactly the same. It's just the underlying I2C that's different. That's something I forgot to mention, is that this card talks to the Raspberry Pi using the I2C bus. So if you look online, there's all kinds of ways to, there's all kinds of information on how to enable the I2C bus on the Raspberry Pi and how to get it to work. So I used Visual Studio Code to get the code on the Pi. It's cool because it has this plugin called Remote SSH, which allows you to basically compile the code directly on the Raspberry Pi. There's not a lot of code here because we're not really doing that much. So if we look at the main that I wrote here, we're starting off in the main function, and we're binding on a port. I'm binding on port 25,000, and then I'm going to set a frequency on the PWM, and then after that I'm just entering a while loop, and I'm just going to stay here forever until I Control-C it to stop it. And whenever a command here, this is it's stopping, so it's going to be stuck here until it receives a packet, a UDP packet, and when it receives a packet, it's going to receive the information in this object here, the SVO object, which has a channel and an on and an off. So for the purposes of my demo, the on is always 0, and then we're just changing the number in the off. If you go back to the Adafruit, these on-off, these are just numbers between 0 and 4095. So we'll talk about that more later. So this UDP class is a very simple class that I wrote also a long time ago. I was trying to write it for both Windows and Linux, but right now I'm just using it for Linux. We don't need to go over it. It's very simple. You can find this online. It's just receiving the buffer and sending a buffer, and what you need to initialize the connection. So I'm using the exact same class on my Raspberry Pi and also on my main computer for sending the message. So if we go back to the main, so this PWM class is the one that I was talking about from Adafruit. So here's my CPP version. If I go to the header file first, we only really need two functions. One is to set the frequency, and the other one is to when you want to set the width of the pulse. I had added another function to be able to set for all. This is just for when we initialize. And then we have this PWM class. If we look at it, basically, so this is the Python code translated to C++, and there's not much going on. The setting the frequency. What I really needed to do here was to implement the I2C. Since it's C++, I decided to use the I2C dev library, which you can install using the command line from the repository, the Linux repo, or whatever distribution you're running. So in the case of the Raspberry Pi, so you can install that library on the Raspberry Pi. I think I put the command up here for that. Maybe not. So anyway, sorry, the I2C. Here, I put it here. So that's how you would get the library installed on the Raspberry Pi. And then you'll need to link with this library. The way I did that is, since I'm using Visual Studio Code, I created a tasks JSON file. I told it to build all the CPP files that are in the workspace, and here's where I added the library, I2C library. That's the I2C dev library. Otherwise, it won't link. So that's the I2C with the PWM. Those are basically the classes that I basically to implement what Adafruit did, and then it's a very simple loop and send the command. So also in Visual Studio Code, so I can build it. I can build it right now. Control Shift B builds it. So we're compiling it, and we're waiting. It's done. Oops. And I can just run it here in the terminal. So now it's running in the terminal. So now it's waiting. It's waiting for a command. So the command, I'm going to send it from a Qt application. I made a very simple window here with, that's my son in the background, by the way. This is the IP address we're sending it to. That's the Raspberry Pi. And then which port we want to send it on. And then which channel that we're going to be driving on the Pi hat, the Adafruit's hat. And then I put a little dial here to be able to change the number fast with my mouse. It makes it more fun. And also a little LED number, LCD number here. I put two because I have two servos, but I suppose I could have put 16 of them or just one. If you go to the slots page, all I did here was I linked the signal of this guy to the slot of that guy, so that when we change the dial, it's going to change the number. And then in the code, if we go to the main window, this code here, I just basically connected the value changed of the dial to this send servo command. So whenever the dial moves, this function is going to get called. I accomplished that by using a lambda expression, which I found in Qt's documentation, how to do that. So this is the first row, and that's the second row, basically. So it's going to send this little servo command object, telling it which channel, and then the 0, like I said, and then the width. This is a number between 0 and 4095. So let's get to it. Let's get to the demo. So if I run it, here's my little window, and then so you can see the rotational one. He's on channel 0. If I bring it up to the midpoint around here, that's where he slows down, and then he goes the other side. He'll go in the other. For me right now, that's clockwise. I go back to about 330, 327. So that's the resting point, and then it's going to turn the other way. So for me, that's counterclockwise, and it'll go faster. So that's the rotational servo. So what I can also just change the channel here now. Let me turn it off. If I put it to 0, it turns it off. Oh, I should show you something, so let me move this here. Here we have the output, so whenever you touch the knob, we're gonna see the command here. So if I move the knob, there you see it. You see the commands being sent. So 182 was the last one. 339, 330. And then I can play with the positional one. I'll turn that one off first. This one. So this one's different. So this one, I noticed that it has a range of 110, approximately 110, and it'll go all the way. There's about 90 degrees, and then it goes to about 550, around there. So that's it. Pretty cool. If I want, I can also put channel 0 here, and now I'm controlling the other guy. That's it. Thank you very much.